Sometimes we need two tubes to come together to create a T-piece, like that. But as we can see, they don't really line up together. So what we need to know is, A, the development of that, to cut this into the right profile to suit that, and also the hole detail on there to create a T-piece. So what we're trying to create is a T-piece. Here we have on my model. So we've got the cutout detail to create the hole in the end to allow whatever liquid, gas, or whatever it can be in the pipework, or air if it's ductwork. And we also need to find this detail here. Either we're making this or we're adjusting the pipework to suit it so it can join together. This is a really handy skill to have in your toolbox. In the world of CNC and laser, even in that world, this is a handy thing to have. Whether we use it a lot, we do use it. Pipes intersecting is quite a common problem. So this method is parallelogram method, and this will solve all the problems. It solves the hole, it solves the cutout detail, it solves making this tube if we need to make this tube, and it solves making this tube also as well. I've done enough talking now, so let's just jump straight into it. So I'll put the basic information on to start with, which is obviously the pipe going to the pipe. We've got the diameter of the tube we're using and how they're going to intersect. So we've created our basic T. Only thing to put in now is this joint detail, this joint line here. Once that's in, we can then have all the information we need to then create the development. The joint line is quite simple. We're going from the center, where both center lines intersect, down to the edge, and then exactly the same on the opposite side. Joint line now fully drawn in. This shows the pipe going up, pipe going across, how they intersect. So the only information is there now for us to start going forward. We'll start with, as always, dividing this base, this cylinder base, into 6. When we're drawing it in the workshop, make sure this diameter, and this diameter is the diameter you're actually using, either internal or external, whichever is more important for you. Yeah, slip this in. It's quite simple. We'll draw as half as development. Use a radius, step it off, and step it off the opposite way. And that will give us the spacings that we need. All these spacings made now, I'm going to number them all up and project them straight up to the joint line. Everything's nicely divided up. We projected the lines up. We can see now where it intersects. Is create on the joint line where both tubes come into place. So this will give us points what we need to develop out on this pattern development. We're going to draw the base, the starting point for this pattern development, and I'm going to use 12 of these. This is half a development, obviously, and all the way around, it'll create 12 spacings. So I'm going to step one of these spacings off 12 times to give us our circumferential length of recreating this. With the base development, we're now clearly drawn there, and the spacings all the way off. Simply going to project these lines straight up. I'm going to project them quite high because I want it to go past the center line of this. All these points projected up. As we say, it's parallelogram method, so all we need to do now is project these points right across there to create a grid. So all we do now is 0 to 0, point 1 to 1, point 2 to 2, point 3 to 3, and back down again. And it's as simple as that. And this then creates the shape of our pattern to recreate this through there. All we need to do now is join the dots, and that will give us this full shape development. There it is, all drawn up, as simple as that. Once cut out, that creates our development for a finished pipe. That is that development on the T. Now we need to just create the hole cut out. We've got this, but we need to know the hole cut out. So for marking the hole out, it's quite a simple procedure. We know that this is half of the diameter of the tube that we're intersecting. Goes from halfway to halfway. Quite self-explanatory. So what we need to do now then is take these spacings, because this is actually a true length, because we can measure that. It's actual true length. Take these spacings, starting there, marking down to number 6 down the length of this center line. All those points are marked on now. I'm going to project these lines across horizontally to create the starting point of our development. Now we've got these points all in place, it's just a simple case of projecting these points where they intersect straight down onto this development. All the marks are projected down now, and as you can see, it creates a grid work. So it's a simple case of not following the numbers because I've got them labelled wrong, but we know where it was going to go, so we need to go 1, 2, 3, 4, 5, 6, 7, and then repeat the process just like so, and that gives us the shape of our cutout. I'll just mark it up now so we can see it a bit better. This is that, finished. That is that. And with this information, we can then place that over our pipe, mark around it, cut it out, and we've got how it should intersect with our development. So from that one simple development, we've created a cutout, and we also get the development, the tube itself, or the wraparound to go around the tube to create the cutout so it intersects beautifully onto the hole we've already developed from the same drawing. As always, geometry has solved this. It's a simple one. It's one to have in your toolbox. Like I said, it solves many different problems with one just simple drawing. It's not just shape, it's understanding the shape. And this is when sheet metal work becomes a skill.